My name is Mike Kieran. I'm a project manager here at CAE Associates, and welcome to the latest in CAE's e-learning series. Today we'll be talking about building flow domains with ANSYS SpaceClaim Direct Modeler. So what's on the agenda? We'll go through a quick introduction. Then we'll go through some flow domain basics and why we'd want to use SpaceClaim. So you have a number of tools at your fingertips. Why is SpaceClaim Direct Modeler useful, and what are some unique things that we can do in SpaceClaim? We'll cover some extraction techniques and simplification tools in SpaceClaim, and then I'll go through a live demonstration of extracting both an internal and an external flow domain. Okay, so who are we? We are CAE Associates. We're an engineering consulting firm in Middlebury, Connecticut. We specialize in both finite element analysis and CFD analysis. We've been an ANSYS channel partner since 1985, so we've been around quite a while, and we've developed more recently our ANSYS e-learning series with the goal of having our customers maximize their software investment. So we'd like to present a number of topics that we feel would be useful for our customers in better utilizing their tools. A few other notes, if you look at our e-learning series and on our website, you can search through our resource library. You can see here part of that is our e-learning series, and we can see in our resource library we have over 250 items and counting. And you can go ahead and search through there. There's a lot of useful tips and resources that you can check out. We also invite you to visit our Engineering Advantage blog, where each one of our engineers here will post periodically, blog entries to share insights from our years of experience performing engineering analysis, on a variety of different topics, both FEA and CFD based. We also have our new training registration and calendar view, where you can see our extensive schedule of ANSYS courses stored at our Middlebury office. And you can visit our CAE University page if you need any help deciding which course would be best for you. Now, as I said, we've been doing these e-learning seminars for over a year now, and we have a complete library of them on our YouTube, on our resource library, and also on our YouTube channel. So you can visit those at youtube.com/CAEAI. And you can view any of our past e-learning seminars, complete library there, again, both FEA and CFD based, and a lot of really useful information to review. One last administrative note: if you're a licensed PE in either New Jersey or New York State, and you wish to obtain a PE credit for your attendance today, we ask that you attend the entire webinar and participate in the polls that we put on. And then complete a short survey that will follow up with you at the conclusion of today's seminar, and then we'll take care of the rest from there. Okay, so let's get into the topic for today, extracting flow domains. So what are we here to talk about? In CFD, one of the first steps in any analysis is to identify the extents of our domain over which we're going to solve the governing equations. So where are we going to solve our problem? Now, a lot of times this requires isolating a section of a larger physical system. So for instance, we have a piping system in a power plant, and we're interested in evaluating the behavior of a valve in the entire piping system. Now, of course, we don't want to have to analyze the entire piping network. We're really just interested in one component, and so we want to limit our flow domain to the area that we're interested in. But we also want to use, be intelligent about where we cut our flow domain. So deciding where the domain begins and ends can have a large impact on the accuracy of your model. So you want to choose wisely. And some of the things you want to think about is, where do I have information about the physical system? So where do I know, within reasonable engineering accuracy, what the flow looks like? I'm going to have to apply boundary conditions, and when I apply those boundary conditions, I want to make sure that they're realistic, and I want to make sure that I cut the flow domain or extract the flow domain such that the boundaries are in locations where I know what the flow looks like, and I can apply reasonable boundary conditions. So all of that should be, you should kind of be thinking about before you ever even open ANSYS or SpaceClaim, or before you turn on your computer. This should be something you kind of draw out or think about before you start your analysis. Now, once you have an idea of where you want to cut the boundaries, what the overall shape should look like, what the extent should look like, now comes the part where you have to extract it. Now, in a previous e-learning seminar, we discussed the procedure for doing this using ANSYS Design Modeler, and today we'll do something similar in SpaceClaim. Ultimately, the goal is the same, but the procedure is going to be slightly different. But with that in mind, we can kind of divide flow domains into two basic categories. We have internal flow domains. These are flow domains that are bounded on all sides by walls. So if we have flow through a pipe, flow through a pump, some internal structure that the flow is going to pass through, that's what we call an internal flow domain. On the other hand, we also have external flow domains where we have flow around an object. So flow can be around a building, around an aircraft, around an automobile, things like that. And so knowing what we're working with is important in terms of what approach we're going to take to extract the flow domain. So why would we want to use ANSYS SpaceClaim Direct Modeler? I have a CAD program. Why would I not want to use that? Why can't I just extract my flow domain in CAD and then bring that right into ANSYS? Well, you certainly can. However, ANSYS SpaceClaim has a number of unique tools that are suited specifically for analysis purposes. So we can import a number of different CAD geometry or CAD files from different programs into SpaceClaim without the need for additional CAD plugin licenses. So we can combine CAD files from different locations. If we have a Pro-E file we want to combine with a SolidWorks file, we can bring both of those into SpaceClaim without any problems. We can directly interact with the geometry in SpaceClaim. So we can directly grab faces, we can pull them, we can defeature them, we can modify dimensions in a really quick and interactive manner in SpaceClaim using its direct modeling techniques that are not always necessarily accessible using traditional CAD programs. SpaceClaim also has a number of geometry simplification tools, and we can use these tools to clean up our CAD files for analysis. So there's kind of two benefits to this. The first is we can do that without affecting our original CAD file. So we can modify geometry in SpaceClaim and not have it affect that original CAD file. Additionally, there are a number of tools here that are geared, uniquely towards dealing with CAD geometry. A lot of times, CAD files have a lot of detail that are otherwise unnecessary for analysis purposes. Whether it's more faces that are necessary to define a particular topology, sliver faces, short edges, things like that. And SpaceClaim can help us defeature or remove those extraneous features. And finally, we have streamlined and simple flow domain creation tools. So we have tools created specifically for the purpose of extracting a flow domain with the goal of doing an analysis in mind. Okay, so let's take a break here. We'll do our first poll and get some feedback from from you guys on what tool you're using for flow domain extraction. So we'll take about 30 seconds for that. Okay, looks like we're wrapping up here. So it looks like most people are using Design Modeler. Hopefully we can show you, we have one person using SpaceClaim, but hopefully we can kind of show you the benefits of SpaceClaim and why you might want to consider that as well. So let's get into what SpaceClaim can do. First and foremost, from the repair and cleanup of CAD imports perspective, we have what's called the repair panel. So in SpaceClaim, we can bring in a CAD file, and we can use our repair panel to help alleviate a lot of these meshing headaches that we typically come across in performing an analysis. So whether they're extraneous faces or short edges or just poorly defined CAD geometry, we can use this repair panel to search for gaps or missing faces or combined surface bodies. We can loop through our model and search for small faces and go ahead and remove them. Another common issue is having short or hard edges or duplicate or inexact edges that will cause the mesher a lot of headaches. And so you can see in our example here, the fuselage, we go from quite a complicated topology where we have a lot of faces and inexact edges that are really not necessary to define the overall shape of the geometry. And we can use the repair panel to produce what you see on the bottom right-hand side, which is a much better description in terms, from a meshing perspective, of our topology. So if we take another look at the small face repair, we can search through our model for small faces, which can be automatically identified in SpaceClaim by supplying a maximum area or a maximum sliver width. And from there, we can automatically repair them. So we can have SpaceClaim automatically go through and figure out how to smooth that local topology and remove those small faces. So you can see in this example we have some screws in our standoffs. We really don't need to have all the detail of the Phillips head screw topology. Certainly not for the purpose of doing an analysis that's geared towards the thermal behavior of the chips. So we want to get rid of that because it'll be a pain in the neck to mesh, and so we can do that really easily and quickly in SpaceClaim. Some additional tools. We have the Simplify tool. If you've ever dealt with some complicated topology, whether it's highly curved surfaces or very very sculpted complex topology, we can use the Simplify tool to locate spline faces, try to simplify them, and convert them into analytic faces. So this can be very useful for meshing, reducing time that the mesher has to take to resolve a particular surface. Very useful tool here. Now, another common geometric feature that we want to kind of simplify or remove from our model are fillets. And so we can use the Rounds tool to remove fillets from our model. So you can see in the example here, we have a rather large fillet just for demonstration purposes, but we can go through and remove any fillets in our model really quickly in a streamlined manner to reduce model complexity. So a lot of really useful tools in SpaceClaim for doing defeaturing, and as we all know, that's a crucial part of any analysis that we perform is ultimately getting our geometry ready for meshing. So the next step, once we have our geometry in a sufficiently defeatured or simplified state that we're ready to extract the flow domain, is to perform that flow domain extraction. So the first type of flow domain we'll talk about is an internal flow domain. And the tool that we're going to use for that in SpaceClaim is called the volume extract tool. And so it's designed for just this in mind, extracting internal flow domains. And we can see for our example part here, we have a turbine blade and we have an internal cooling pathways, and we want to extract the internal flow domain from there. And so that the way we do that in SpaceClaim is to identify the openings which the flow can escape from that internal flow domain. And so we have two choices to do that. We can select the surrounding edges of the opening. So you can imagine if you have a simple geometry where you have one inlet and one outlet, you can just select the inlet and outlet edges, and that will define the openings of the flow domain. Or conversely, you can choose a face that defines where the openings occur. So if you have a more complicated geometry with many openings and many locations where the flow can come in or out, you can just select a face that encompasses those openings, like in this example, we've selected the top face of the turbine blade, where we have 3 openings, and that'll more easily identify those opening locations. So SpaceClaim will internally resolve where the gaps are on that face. So once we've defined where our openings are, you can imagine in a complicated geometry, you may miss one, right? You may not necessarily catch all the openings. Maybe there's a leak. Maybe your CAD geometry is poorly defined, where you have some issue where 2 parts are coming together, but they're not completely sealing off the flow domain. Well, a really useful tool that we have in SpaceClaim is called the Preview Inside Faces. So once we've selected our openings, we can drag the Preview Inside Faces bar from left to right and see how the flow kind of goes through our model. So you can see on the bottom left-hand side in our picture, the solid geometry is transparent. We have on the top right-hand side of the geometry our opening face selected. And as we drag the slider bar from left to right, it's going to extend the face selection that defines the internal flow domain. So you can see as we progress along the pictures in the bottom, the internal flow domain filling up, and we can detect whether it's capturing all the faces of our internal flow domain, or whether it's escaping and capturing things perhaps that we are not included in the internal flow domain. And so this picture sequence, or the slider bar, allows us to visualize where the flow goes before we extract the flow domain. So we can catch any errors. We can easily kind of take a look at what we expect that to look like before we extract our flow domain. So a really useful tool here for internal flow domain extraction. Now, for external flow domains, we have a little bit of a different concern. We don't have any geometry naturally bounding the flow in its outer extents. And so what we want to do is ensure that the domain is large enough such that there aren't large flow gradients normal to the boundaries. So we like to use the rule of thumb here based on the characteristic dimensions of whatever external flow geometry you're studying, using a width and a height, where we supply at least 2 times the height in front of our object, and oftentimes as much as 10 times the height behind our object, and ample space in the width and height directions. So again, that we're satisfying that our flow gradients aren't large, normal to the boundaries. And so this is just a rule of thumb for any given geometry. You may need more, or can get away with less, flow domain than what we're saying here. But just usually or typically a good starting place for extracting your flow domain. And so how do we do that in SpaceClaim? Well, in SpaceClaim, we can use what we call the enclosure operation. And we can use this for external flow domains, but sometimes it's also useful for complicated internal flow domains as well. Essentially what it's going to do is create a body surrounding your CAD part and automatically perform a Boolean subtract to define the flow domain. So it's going to create a whatever shape you tell it to, whether it's a rectangle or a sphere or some custom shape, in the size that you instruct it. So based on some slack value, say you want it to be 100% bigger than any given dimension of your underlying CAD part. It's going to generate that body and then subtract out your solid material so that you have the flow domain. So a really easy and streamlined tool for extracting external flow domains. Okay, let's break for our second poll, and then we'll jump into a demo of extracting flow domains. So here we'll ask you for some feedback on what your biggest challenge is when preparing geometry for CFD. Okay, just a few more seconds here. All right, looks like everybody's got their answers in. Let's take a look at okay, so it looks like for the most part we're evenly split between geometry simplification and CAD cleanup and updating models to include geometric changes. So I think SpaceClaim can help help you in both of these areas. Certainly the simplification and cleanup, but as well as updating models for geometric changes. A very streamlined process in SpaceClaim. We've put on some other e-learning seminars that you should certainly check out if you're interested in seeing how SpaceClaim can modify geometry. But right now, let's take a look at extracting flow domains. So I'll come into a workbench here. And first, let's take a look at extracting an internal flow domain. So I have a valve geometry here. I've dragged it onto my project page, and let me right-click on that and open SpaceClaim. So this is going to automatically open up SpaceClaim Direct Modeler. It's going to be a little bit of a different interface than you're used to in Design Modeler. But it's going to automatically import that geometry, and then we'll be on our way for extracting a flow domain. All right, here we go, almost there. Just opening that file now. And of course it opens on my other screen. Okay, so let me bring that over here. And let's take a look. So we have this valve geometry here, and so we can kind of spin it around. We have some piping on the ends here. We have some internal components, and so let me just change these to be transparent so we can kind of see through them a bit. Make these transparent here, and get this last one here. So we have a pretty simple internal flow domain, but we have some, in terms of the openings, but we have some complicated geometry on the inside. And so let's take a look at how we'd extract that flow domain. If I go over to my Prepare menu, and I click on the Volume Extract tool, the first thing I'm going to do is select the faces that define the enclosed or enclose a particular region. So if I select this end here, that's going to be my first face that defines the enclosure. Now, the next thing I want to do is hold down the Alt button and select this internal face. So that's going to tell it essentially which direction to go once it starts creating that flow domain. And finally, I'm going to select my other opening on the other end here. And so now it's going to try to essentially go from one opening to the other that I've selected. So if I do the Preview Inside Faces, and I start on my initial side on the right here, and I drag the slider bar here, you can see as I'm dragging it, it's extending that face selection and extending the flow here to show me what my flow domain is going to look like. So I can kind of visualize before I ever extract the flow domain what it's going to look like. I can see if I missed anything. Maybe if it's capturing some faces that I'm not particularly interested in, or maybe there's a gap in my model. I can visualize that using this slider bar. So a really useful feature. Once I'm satisfied that the flow domain is sufficiently defined, I've picked the right faces and it looks good, I click this check mark here. And if we just hide all these other bodies, now I can see I have my internal flow domain. So looks great. It looks exactly what I wanted. I can go on and bring this into the mesher, start generating my mesh, but a really easy tool to extract that internal flow domain. Let me start opening my external flow domain. Now from here, I could also go ahead and perhaps search for small faces. Let's say if I do a search for these small faces here, and I specify some threshold. Let's keep making it a little bigger. Say 1 square millimeter. So it's going to go ahead and find any face that's smaller than 1 square millimeter, which includes a lot of these faces in here. And then I can go ahead and repair those or remove them. Maybe if I make it a little bigger. Now it's got all these fillets in here, and if I go ahead and try to repair them, it'll go ahead and remove those, get rid of those fillets, in a really easy, streamlined manner. So not a whole lot of work on my end. All I have to do is search for them and have SpaceClaim go ahead, find those small geometries, and try to remove them from the model. So now I have a much simpler, geometric definition. I don't have as many small fillets, much easier to mesh. Okay, so that's what we do for internal flow domains. Now let's take a look at an external flow domain. So I bring this session over here. This is almost going to be even easier than the internal flow domain. I have my fuselage geometry. I'm going to come over to the Prepare tab, and I'm going to use the Enclosure tool. If we see on the left-hand side here, the Enclosure tool, I can use a number of different shapes, whether they're a box, a cylinder shape, a sphere shape, and I'm going to specify a cushion. So if I specify a cushion of 25%, it's going to take the dimensions of the underlying CAD geometry and use 25% of those dimensions in a particular direction as a cushion for the flow domain geometry. So if I want to specify, let's say, 100%, and then I pick my fuselage or my airplane body, you can see it shows a preview here of what that shape looks like. So for now, I'm just going to accept what its default shapes. It's using a particular value based on the underlying geometry. I hit the check mark. But based on our conversation before of what we're looking for in terms of the geometry dimensions, it's probably not exactly what I'm looking for. So what I can do in terms of making it longer in any particular dimension is come over to the Design tab and use my Pull feature. Now the Pull feature allows me to grab any face and just quickly pull it in a particular direction. So I can pick this face here, I can pick this face here, and now I can give it a little more slack really quickly by just grabbing these faces and pulling them away. And so that allows me to kind of, at least visually, say, okay, this looks a little better in terms of what I'm looking for in terms of characteristic dimensions. Again, this doesn't need to be exact because it's just a rough, we want the boundaries to be far enough away, but we don't need them to be, any particular dimension down to, the 5th decimal point. So we can use this pull feature to quickly manipulate the geometry and have the flow domain look like, roughly the dimensions that we need. And that's all there is to it. So a very simple and streamlined process. SpaceClaim makes this very easy, extracting flow domains, whether they're internal or external. And we can do, in addition to that, a number of different geometry simplification procedures. So whether it's searching for small faces or short edges or anything like that, we can do those in SpaceClaim without altering the original CAD file. And we have our two tools. We have the volume extract for our internal flow domains where we can preview the flow path, and we have our enclosure operation for our external flow domains. And that's all we have. So hopefully you enjoyed our e-learning seminar today, and if we have any questions, we'll open up the floor